This video is a continuation of our last video. In this video, Mark is planning for retirement, and we were able to calculate the amount he would need in his account in order to withdraw $1,000 each month for 30 years. In this video, we're going to move ahead and we are going to look at Part B. Part B asks us, how much will he have to deposit each month for the next 40 years in order to get this balance at retirement? This problem is slightly different than Part A. In Part A, we knew how much we were going to be taking out, and so we had to get that amount in our retirement account in order to make those withdrawals. In Part B, what we're looking for right now is how much we're going to have to save up. This is a little different. Instead of withdrawing, we're actually doing some saving. In other words, we're saving money into an annuity. That's what's happening for Part B. Let's refer again to our financial formula sheet that's located in Canvas. On that sheet, we're going to again look at the annuities, but specifically this time, remember, we're looking at depositing money into our retirement account. So this time, our scenario is we are going to be making money deposits into our annuity. Those deposits are going to be made periodically, and there's two particular formulas that we need: the total amount in the account and the amount of each deposit. Now, which one are we specifically looking for? If we go back and look at our problem, we are looking for how much will he have to deposit each month. So we are looking for the monthly deposits. Let me go back to that formula sheet one more time. We are looking for the monthly deposits. So we are going to be looking at this formula on our formula sheet. What is the amount of each deposit for an annuity where you're putting money into a retirement account? Let's copy that formula and take it back with us to actually solve the problem. Bringing that formula over, we have that the amount for each deposit is D, which is our scheduled deposit, equals P sub N, or the money in the account after N years, times the quantity of R over K, where R is the interest rate and K is the number of compounds per year, also the number of withdrawals per year, over the quantity 1 times 1 plus R over K to the NK minus 1. This formula will help us determine the deposit Mark will have to make each month for the next 40 years in order to get his balance at retirement. Our job is to take all the pieces from the problem and put them into this formula and then calculate that deposit amount. So let's look at what we have. We're searching for the deposit each month, so we're looking for D. We have P sub N. P sub N is the amount in our account after 40 years. And that was what we actually solved for in Part A. Mark needed to know how much he wanted to have in his retirement account to meet his goal. And he will need $195,067 in his account. So P sub 40 is that number. R is our interest rate, and the interest rate is still the same. It's 0.046%. And K is the compounds per year. Because we're depositing each month, K is going to be 12 because there's 12 months in a year. And N is our number of years. Now, be careful here. He wants to deposit money into an account for 40 years. He's not going to retire until 40 years from now. So 40 is actually our number for this part. 30 applied to the money he was taking out, but 40 is the number we're looking at when 40 years to put money into an account. One other thing that I like to get is that NK, or N times K, and if we take N times K, that's going to be 480. We can now take all of that information and plug it into our formula. So our formula is going to be that D equals $195,067 times 0.046 over 12, all divided by the quantity of 1 plus 0.046 over 12 raised to the 480 minus 1. As before, we're going to take that expression just as it is, type it right into Desmos. Adding that expression in from what I typed in Desmos, just to compare and show you it's typed exactly like we've written it down. The only difference would be in Desmos we can't put commas, right? So we have $195,067. We're going to multiply that times 0.046 over 12 and then divide by the quantity 1 plus 0.046 over 12 raised to the 480 minus 1. And Desmos computes it and spits out the following: 141.77022238. Rounding that to the nearest cent tells us that the amount we have to deposit each month Mark will have to deposit each month for the next 40 years is $141.77. That's our amount right there. Okay, and that brings us to part C. And in order to do that, I'll create one more video, okay? So we'll do part C in the next one.